this is where things get a little more complex because we have a lot of options in database land. We have the SQL databases. We have the document data stores. I guess I'll call it database. Document databases. I'll put examples: SQLite, PostGRES, MYSQL. Please don't use Mongo unless you have a very specific reason. But I find a lot of people don't think about things this way, which is a little confusing to me because KV is a subset of database like functionality. Document DBs are a superset of KV, but a subset of like relational SQL type databases. I'll say relational/SQL DB. And then relational DBs are additional functionality on top. Databases. Everyone needs them, kind of. How do you pick one? There are so many options now, from different SQL providers like Supabase and PlanetScale to like NoSQL providers like FAUNADB and FIREBASE to like cached edge solutions like Worker KV and Cloudflare. All of these solutions provide the basic need of, I have data that my users have created. I want to store it somewhere and access it later. But all of them work very differently and solve very different parts of that problem with fundamental different philosophies. And it's way too easy to pick the wrong data solution for what you or your project need. I want to talk more about how these databases differ, and more importantly, how you can pick the right database for what you specifically are building. With that all said, let's dive in to everyone's favorite app, Excalibur. Databases, how to choose one. So let's start with a basic definition. An external thing that stores data. By this definition, a lot of things can kind of fit into database, including everything from, Redis arguably would fit into this definition here. Obviously, Worker KV would fit into this definition here. Obviously, SQLite would too. There's a lot of other things. Even some weird like WebSocket providers kind of are a database in the sense that it's an external thing that holds state or stores data. But usually a database is something that persists the data that you can access over time. So usually persisted data, usually accessible via API. I think that for the sake of this stream, that operating under this assumption that a database is a thing that externally stores data, persists it, and can be accessed via some form of API is a good enough way to get started. I should say standard client. I would consider, I don't know if I'd call SQL an API, but regardless, I think this is a good framing to start from. So what are the options? This is where things get a little more complex because we have a lot of options in database land. We have the SQL databases. We have the document data stores. I guess I'll call it database. Document databases. I'll put examples: SQLite, PostGRES, MySQL. Where document databases are things like MongoDB. I don't know what I'd call FAUNA. Though SQL relational, like FAUNA, or I guess is Firestore. I guess Firestore is kind of a document DB. There's a lot of like line blur between these two, depending on how they set things up. Firestore, everybody's saying Firestore is Diet Mongo, which is scary. So we'll put Firestore here, and I'll put, what's the weird one that is like the GraphDB? It's like N something. Neo4j. I'll call these Graph. Yeah, that's a lot of people saying Neo4j. Thank you all. So we now know what that one is. Yeah, and then there's KV stores. That's the last one, stores, which are things like Redis, Worker, KV. I think this, I'll put memcached. Cool. Yeah, KV stores can be in memory. They don't have to be in memory. I think that all of these, as far as the architecture of the database and how things like are stored in DB, that these are the different like categories we can think of in terms of how it affects our data architecture. DynamoDB is a weird thing, and if Dynamo's the right solution for you, you're not watching a beginner DB video on how to pick your database. You already know Dynamo's the solution for you. You're smarter than me. Go use Dynamo. We're talking about how to pick your first database for your small side project right now. Dynamo's for Amazon scale. Dynamo sucks to use. You've picked it for a reason. I trust you. Go use it. Don't talk about it here. Thank you. Anyways, what are the types of database? I think it's important to start with this distinction. Like, what are the different types of databases? Because that's separate from the next question, which is, where do I host my database? And this has a lot of different, like, I'm trying to remember the way to break this down. The original, like, OG solution that a lot of people still do, that I sometimes miss, usually don't, is run it on a server yourself. Those would be things like AWS, EC2, things like Railway, Heroku, etc. What these solutions do is they actually spin up a box on a server that is like a Docker image, effectively, like an actual separated container that just runs the SQL or server, or runs the EdgeDB, or runs the Neo4j, but it's a box that runs that like database directly. You as the developer have to know which provider you want to use, how to deploy that container for it, and also pay attention to like when it hits limits and make sure it scales accordingly. You can run this on Kubernetes, but please, as Aiden just said, do not put your database in Kubernetes. You're going to have a very bad time. Anyways, now that we've discussed running it on a server yourself, there are other solutions like hosted or provided, scaled, auto-scaled hosts. This would be things like PlanetScale and Cockroach DB. There's a bunch of others people are going to suggest. I guess this falls under managed. Do I just call it managed? The problem with managed is it's kind of a group. Like, there's like two tiers of managed almost. So there's provided auto-scaled hosts on OSS Tech, which are like PlanetScale and Cockroach. And then there is proprietary, very infra tech pairings, which is things like FAUNA. Yeah, I think FAUNA is the one I really want to call it here. I guess Worker KV, kind of, where you cannot run Worker KV on your own servers. That is running through their stuff. Durable objects, kind of DB. I don't think durable object really fits into any of these definitions. We'll get back to that one. I almost think there's like 3 tiers of managed, which is, I don't know how to say this tier other than boring, which is things like Supabase is what I'm thinking of here, where like you can host Supabase yourself. They just host it for you. And when you get close to a limit, you click the button in the UI and promote yourself to the next tier. But it's not proprietary because it is open source. When I brought up Railway's under run it on a server yourself. You're still thinking about the box. You're still thinking about the performance of the box. Supabase is a tier. Like if I go to the Supabase pricing, you'll see that the way the pricing and like scaling works on databases is by like the amount of storage you're taking and the amount of bandwidth and the number of monthly users rather than the size of the box. Where if you go to Railway's pricing is much less based on the usage, like the number of users and the number of queries. It's based on the size of the box and the specs of it. So it's how much like disk does this box have? How much CPU execution time are you spending? These are like, it's almost like a level of, or like a spectrum of how much of the concern do you want to own? So we're going to draw a diagram. where on one side of this is I run my DBs on bare metal, wrap that better. And the other side, what's a database? Is it like Airtable? So these are the two different sides that a developer can live on in terms of how much you give a shit about the database and how much you understand and know and care about how like the database and the data models work. You can fit into a lot of different places on the spectrum, and there's a good reason to be anywhere on it. If we're talking about something like, let's scroll up, running Postgres on EC2 yourself, I would say that fits around like here, Postgres on EC2. And then there's solutions for people who care a bit, but don't want to manage it. They know what managing their DB hell is like. So PLANETSCALE handles scale for me. And then there's like SQL. I'll just use the Supabase client. Need to shift these all down slightly. Make more room. Actually, I'm going to shift this slightly because I want to fit Railway in here somewhere. I think it actually fits somewhere like here, which is I just need SQL quickly. I'll throw it on Railway. So here's a spectrum where on the left, you know what the fuck you're doing and nothing I talk about is going to convince you. And on the right are people we scared away long ago. I think this is the spectrum of how much do you care about your database and your data? And how much are you thinking about like the scalability and maintainability long term? And you could also argue that with this line, the left is following the standard. The left doesn't know what standards are. There's also a pretty strong line, I would say, right about here, where everything to the left of this is standard and like following SQL as much as it can. But once you get around here and go right, the Supabase client isn't SQL, even if Supabase itself is based on top of SQL. But how do I put it? Like Supabase being SQL based means the safer bet, not that it's a standardized bet. And you can move off of Supabase's client to something else like Prisma that is based on top of the SQL standard and use the same database, but you have to now do that. And moving out of Supabase before you've moved off the client is nigh impossible. So on the left here, we're following standards to a T. And as we go further right, we're leaving those standards. You could make an argument that PlanetScale is less standard than throwing a SQL server on Railway, and you'd probably be right. But I would argue both of these follow a specific open source SQL standard. Railway lets you pick the one you follow. PlanetScale uses Vitesse as like the scaler for MySQL. But this is like, if you picked PlanetScale, either you care enough to know or you don't care enough and never want to worry about it again. Both of which I think make sense for picking PlanetScale. It's like the scalable subset of the standard, whereas Railway's the non-scalable superset, trusting you to handle the scale in the future when you need to specifically. So I also just noticed after Ollie brought it up in chat, I didn't put Mongo in here. I have to expand this to make room for Mongo. Do I really put it slightly less far? I think I do. Shit. But now in order to keep this balanced, I need another thing. I guess I'll just put this here. And I need one more good thing to squeeze in to keep this balanced better. Elasticsearch isn't a common enough thing. You use Mongo and Go? Oh God, Aiden, you've scared me. So I only want to talk about things people could actually ship. EdgeDB is not like something I would ship yet. Very new. Oh, somebody made a funny one. I think WordPress has something built in. There we go. We're balanced again. There we go. How do we feel about this in terms of like a framing? Do we agree thus far that this is like the spectrum of how much people care? I haven't gotten into how we actually make a decision yet, but I think this helps like where these solutions fall in terms of how much you need to know and how much and who is picking these different solutions. PlanetScale is to the left of Railway because technically speaking, it's a lot more... I'm 50-50 on switching these two, honestly. It's the thing is like PlanetScale, this is meant to be like left is people who care too much and right is people who don't care as much. Railway is the solution for people who care enough to want the SQL standard, but they don't care enough to spin up like Postgres or do things right, infinite scalability with PlanetScale. Like the way I'm thinking about it is I start somewhere to the right and I move down the spectrum as the app grows. So I can see myself starting on Railway as like the initial DB, and as the app grows and like the scale we're working at gets bigger, I can move to PlanetScale at that point. Prisma doesn't fit into this. For the person who asked, Prisma is a way to connect to any solution from here down, but it is not a method to actually define your database itself. Like Prisma is not a standard for defining deep data. Prisma is a method to connect to an existing database. Sankdoki, no, with Railway, let's get a DB URL with Railway quick. Dev.new, provision Postgres. How about calling PlanetScale Vitesse? That's honestly probably a good point. Yeah, Vitesse probably would have been a better thing to have said there, now that you mentioned that. Good call. Yeah, Railway lets you publicly expose your DB. You're like supposed to. Here is my connection URL and my connection command. They are right here, auto hidden. I can copy it. I now have a Postgres DB I can go use in dev or even in production. Yeah, you can use things internally, like you can cluster your like Railway app with your Railway like server inside of Railway and have them connect in no external connection method. As far as I know, I don't do that. I don't care. I just connect using the credentials that are exposed here. Railway is the quickest way to just throw up a Postgres instance like immediately. Somebody said swap Mongo and Supabase. Are you joking? I want to push Mongo further that way. You shouldn't use Mongo. Like unless you have a very specific need. Do I go on a separate like Mongo tangent? Please don't use Mongo unless you have a very specific reason. Cool. So let's talk about Mongo. Mongo is a document store. It is glorified JSON. JSON isn't bad. I want to be very clear about that. This isn't JSON is terrible and that's why Mongo is bad. It's JSON is a structure that represents your data. Data is more complex than blobs and documents. If you have arbitrary JSON blobs that have no relationship to each other, and you want to store those in Mongo, go nuts. That's fine. But almost every problem has relationships. I'm going to write that one out here. Almost every data problem has relations of some form. There are so few exceptions to this, and believe me, I wish that wasn't true. I genuinely do. But every time I am deep in a code base, especially ones that adopted Mongo, most of the problems we end up seeing are weird selection patterns that have to be developed because there are different tables and different document types that represent different things without relationships between them. So if we have a user object in DB, we have a user. User has some properties. It has ID. It has name. And it has comments. Comments are all the comments this user has left. Oh shit. So how do we like store comments in here if it's a document? Well, if we want to store it in here, we can expand this and have comments be a subtable in here that's like segmented off. We have like comment 1, 2, 3. But then comments can have reactions. Okay. So now we want to break these out even longer. And now, God, I'm just going to do 2 comments because 3 is going to be so annoying to manage. So comments now in here have whatever subfield exists within it. So we'll draw this split. And each comment now has reactions. But each reaction that exists has a user ID for who reacted. So how do we get those user IDs? We end up firing another query back to user to fetch all of the same data again. It sucks. How does this work in a relational model? I wish I had made a clone of this earlier. I'm going to yoink all of these things out of the way. So we have all of this here in our model. Now we might have a second model, comment. And a comment has an ID of its own, a user ID, and maybe body or content, we'll call it. And we'll also give it reactions to keep it consistent with the last example. Reactions. So now I can link comments here, and this link goes both ways. I wish there was an easier way to do a two-sided arrow. I think that there is, I just don't know it. But these are like intrinsically related now. There's a link between, I should actually link this to user ID, which will point there. And then comment points to the IDs here. So now we have a relationship where user has comments, and we can now select all of the comments a user has via a foreign key. And the comment has a user ID, which is the foreign key that identifies which user this comment is linked to. We now have the ability to define this relationship. So now if we want another thing later on, let's say when we first build the app, comments don't have reactions. They just have the ID of the user and content. But then we get a new PM, and that new PM really wants reactions where you can react with a smiley face, a different emoji, multiple people can react in different ways, and we sort them and do all this crazy shit with it. Now we can create a new table that's very similar. That is reactions. And reactions are probably going to have pretty similar contents where it has an ID, but it also has a comment ID, which is a foreign key that links this reaction to that comment, and an emote. It probably also has a user ID, so it can link back to user. And then the emote, which is like the actual content of this thing. So now we can link this user ID all the way back to the user table. And now user knows all of the things it's reacted to as well. You don't have to label that in there, but it does exist. And we can link back the comment ID here too. Now this diagram isn't the prettiest, but the goal here, the thing I'm trying to represent, is that when you add additional things, you can define relationships between them that make it easier to add and remove things and not have to just keep expanding your data model and running huge migrations and changes on top of your data. With something that is a document instead of a set of relationships, you now have to either think of all the potential relations ahead of time when you initially start the document, or you have to eat the insane cost of the chaotic migration experience in Mongo, or, and it's what I'm seeing the most, you just don't bother. You make these new tables, but there are no links between them, and then you just do that all in user land. It sucks. It sucks really hard. If you have problems that are never going to look like this, like let's say you're building a log system and you're literally just saving a log, like you want the text content of a log someone sent, and that's it, then go do that in Mongo. It's a good solution for that, to just write endless shit. Go nuts. But it's not the best solution once relationships start getting involved. An interesting article I read recently was actually discussing no relationship SQL, because joins are, I don't want to say they're slow, because joins are very fast. But once you get to the scale of like Amazon, very fast isn't fast enough. You want linear lookup time always. At that point, you can use something like Dynamo with one table, and you basically turned DynamoDB into Mongo, but way, 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 way faster. A more general way of thinking about this is, I need more space for this. So to go back to here, where we have the different types of databases, I want to ignore GraphDB for a bit. So pretend that's not there. We're going to talk about the other three: SQL, document, and KV store. So I'm going to draw a circle here. This circle is a KV store. This is all of the functionality that a KV store can possibly provide exists within this circle. Here's another circle. This circle is a document DB. This is something like Mongo. All of the stuff a KV store can do, a document store can do. Slower, but it can do it. A SQL database can do everything a document store can do. I will be very clear about this. You can have a single table in your Postgres database with a single field that is a JSON blob and treat Postgres just like Mongo. You have that option. It is a thing you can go do. I don't necessarily recommend it, but honestly, it's pretty powerful to start with a relational SQL database without the relations and then add those in the future as you need them. But I find a lot of people don't think about things this way, which is a little confusing to me, because KV is a subset of database like functionality. Document DBs are a superset of KV, but a subset of like relational SQL type databases. I'll say relational / SQL DB. And then relational DBs are additional functionality on top. So depending on the types of problems you run into or the thing that you're building this for, like if you want a cache that you look up a URL and it gives you back the HTML content for that URL, a KV store like a Redis or a worker KV is probably the best solution, because you want the fastest possible. You look something up and you get it back immediately, and you don't care about the shape or the relations. KVs can be faster for that specifically. But if you're looking at something like worker KV or like Redis for the developer experience or for the method of defining your data, if you don't have the specific performance needs that worker KV and other KV solutions solve, don't use them, because you're going to run into other problems that something like a document DB can handle better. Now let's talk about document DBs like Mongo. It's going to be way slower than a worker KV or like other KV stores, and a little more limited in terms of it's more limited than like a relational DB, but you still have a bunch of functionality like normalizations, lookups by subkeys, other things that make a document DB viable. But those things don't solve the higher level data architecture problem of I have these two different things that have a relationship between them. We need to define those relationships. And that's when relational DBs become the solution. So when I make a decision about a data solution, I usually start from the top here in relational DB land and ask, okay, this solves everything. Can I trim down? Is it possible for the problems that we're building to have no relations and to not need lookups that are crazy? And if so, can we go all the way down to a KV? Can we have the simple base tier solution? And if not, why do we need to move out? And what I find is in the vast majority of projects, you will eventually have something that resembles a relationship, at which point a relational DB makes sense. Generally speaking, MongoDB does not make sense for applications because applications tend to have relationships. There are a lot of other types of tools and things that document data stores make sense for. Applications is definitely not one of them. I want to be clear, I'm not saying document DBs are a subset of relational DBs. I'm saying that the functionality they provide is a subset of relational DBs. The capability of the data architecture I can create using a document DB. There is nothing I can create via a document database that I can't do via Postgres, via JSON blobs. That's the difference here. It's not that document DBs are a chunk of SQL. That's not what I'm saying here at all. You have to go out of your way to misinterpret my words to think that. What I am very specifically saying is that the functionality provided by document databases is similar to that of what you get from JSON blobs in SQL, so much so that everything you can do in a document database can be done in relational DBs as well. Anyways, What else did I want to complain about? Is it time for the Firestore rant? Might be time for the Firestore rant. Please don't use Firestore. This guy's going to need its own whole section. Firestore is another one of those important technologies. Challenge the way we think about databases in a really important way. Before Firestore, databases were a thing that your server wrote and read to, and everything between the server and the client was your problem as a dev. Firestore challenged that norm by asking a couple questions that no other providers did at the time. The unique things that Firestore asked was, what if the client can define the request, the things it needs, without a server involved? And what if the client updated automatically when the database's content changed? One of these questions was a good question to ask. I think that the second question here of what if the client updates when the database content changes is a very interesting question that solves a bunch of very real problems. However, the first question is a disaster waiting to happen. Almost always. Ollie, quick correction. Firestore is not Firebase. Firebase is the superset of other tools and things that Firebase provides that Google has, like for their auth and all those other things. Firestore is just their data solution and the method to access and work with it. I have been convinced by some friends at Google that there probably are other things in Firebase that might be of value sometimes, but I cannot get a Google employee to sit down with me and defend Firestore right now. Firestore is a shit show. So, why? How do I properly describe? There are a lot of technologies that, how do I put it? There's a lot of different technologies that served a very important role of handling or of proving out a new developer experience and workflow that brought a lot of value. Things like Angular, proving that building applications in the browser with like well thought out pieces is valuable. Things like React, proving components are a really strong architecture and way of defining things. Tech like Jest, showing us ways to do unit tests. Tech like, do I even bring up Enzyme? Yeah, Enzyme's dead for good reasons. It showed us that tests are possible, but how they can feel like shit. But it showed a lot of the benefits. Like these technologies, even if a handful of them are not things you should ship today, all proved out concepts that as a community we have learned a lot from. Sadly, when those things happen, because of how strong of a proof they demonstrate, they tend to stick around for longer than they should because they blew up somebody's brain, showing them here's how the future can work. They buy into it really early. And then when we actually get to that future, they're not willing to move off it. And I think that's where we're at now with Firestore. So, what went wrong? There's a few different parts here that I want to like go more in depth on. We're going to start with the what's changed outside of Firestore. So, things have changed. There are better options for the live part. Supabase is the big one. We're also seeing new providers like Cloudflare's durable object to an extent. I know Convex is a newer one that I was chatting with at an event recently. What are some others? There's a handful of people that are doing this now, and also interesting partnerships starting to happen. I would expect Prisma to include a WebSocket for syncing of some form. I don't know if Convex is worth it. I had interesting interactions when I talked with the team, but it's a very interesting new solution that I'm seeing more and more of. So what went wrong? There are better options for the live part. Google bought them and things have stagnated. And honestly, I think the biggest thing is we pendulum swung back to SQL. For a little bit, we as like a community weren't sure if we liked SQL still or not. And I think we have now accepted that SQL is good and we should probably use it for things. Firestore did not believe in SQL at the time. I think that was where we're going to get into like the two bigger issues with this first part. SQL is good and standards are good. And also, very importantly, servers are good too. So things have changed. We'll make these next sections. Servers are good. I guess that I can keep this all in one text block. It'll make my life easier. Servers are good, actually. And I'll fill that out in a second. And SQL is pretty nice. So what do I mean when I say servers are good? I mean that we should, or developers can and should think about the shape of data separate from their databases. The things users request should be different from the way things are stored in DB. And I think I'll start with these two parts. I guess I'll have permissions. GL have fun, or good luck have fun on client. So when you use something like Superbase or like Firebase, and you use their client for Firestore in your iPhone app or your website, you don't have a server that is hitting the database, finding the right fields, and giving them to you. You are using whatever Firestore already wrote to access and change things. So if I have an app where on the homepage, I'm fetching the top 50 tweets, and then once you get to the end, I scroll and fetch more. There is no batching in the Firestore client by default. So there are a lot of apps that are using Firebase that are trying to use the Firebase client because they don't want to build a backend, that have to fetch thousands of rows of data just to show you the homepage, because people commit to not having their own backend, not handling the different shapes of data and ways that clients might consume things differently from how Firebase prescribed you access Firestore. It's hellish. There is no solution that will auto-magically give you every unique API your clients need. And the only way to consistently build the APIs your client needs is to build them. I want to make the cost of defining the right API cheaper. I don't want to erase the API entirely. In solutions like Hasura, solutions like FAUNA, solutions like Firestore are largely betting on this idea that you don't need a server. We are your server. Configure some things in our weird UI, handle permissions through a YAML file in there, and now you'll get absurd errors on the client when you do the wrong thing. It's a shit show. And what you end up finding is, much like SQL, there are things you have to learn and understand a bit of, but unlike SQL, those things aren't standards. You have to learn all about Google's unique opinions around configuring permissions, or Hasura's weird way of architecting data so that the right user can write over it, but not certain other users. What you end up finding is, even if you do adopt one of these solutions, you either realize you need a server, so you build the server, or you ignore that you need a server and you do very, very suboptimal and often even insecure things in order to make the app fucking work. The reason Firebase succeeded, very specifically, and I'm not even saying Firestore, Firebase as a whole, succeeded because backend was too hard. And it was. Backend was way too hard. We fixed that. That problem is gone now. I don't want to say backend is easy, but backend is easy enough now that this shit doesn't make sense anymore. I think that we reached too far because backend was hard, so we don't want any more. I'm building an iPhone app. I shouldn't have to build the server. I'll let Firestore handle all that. It sounded good at the time, but we did get good pieces. There are things in here we can steal that bring a lot of value. The automatic updates thing in particular. We're seeing other solutions realize that there's value here. I even have a diagram I did a few days ago. Here we go. WebSockets are a way to trigger updates without having to pull or request data. I think that what Firebase or Firestore specifically was doing in terms of using WebSockets to synchronize the client with the database was very interesting. And we're starting to see more solutions take advantage of that. Convex was very proud to say they're the thing in the middle here, the question mark, but their event system kind of sucks. So they really are just live data sync and DB sync right now. And even then, I talked to them about their live sync, and it seems like their philosophy is still just put it in database, which I don't like. I am genuinely really into how we're starting to think about database sync as a unique problem. And I do credit Firestore for forcing that conversation, for getting us to think more about what is the relationship between our database and our client, and how do we keep these things in sync in a meaningful way. I'm going to rename this one to database rant so I don't forget about it in the future. Cool. So I'll do a quick, what did we learn here? SQL works great for most things. There are real DX wins happening all over. Please reconsider Mongo. Please don't use Firestore. And servers, APIs are good, actually. I'm happy with that. I hope that this can help people make better database decisions. Please use something that's a standard if you can, and if you can't, make sure you have a very good reason. I don't have much to say about GraphDBs. They're too new, and I don't. Yeah, it's too early for Edge DBs. Everything I talked about here, I would even Firestore, I would somewhat confidently ship in production. It's been around long enough and enough people are building on it. None of the GraphDB providers are standardized enough and old enough for me to trust. Yeah. I like Humanoid's point. If you think you need a GraphDB, you probably don't need a GraphDB. Candlekin asked, would I put DynamoDB and Mongo in the same bucket? No. I mentioned this earlier. If DynamoDB is the right solution for your problem, you're probably not watching my streams because you're a database person. They're smarter than me. Y'all, if you're using Dynamo, you probably have a reason for it, and that reason's probably good. If you're using Mongo, you probably don't have a reason for it. Generally speaking, from my experience, the people who I see using Dynamo have a good reason for it and somebody who knows what they're doing. The people who are using Mongo just shrugged and picked Mongo, and now they're stuck with it. I saw that Ollie mentioned that the thing that Firebase and Firestore enable are small teams to be more effective. What does Firestore enable for small teams to be more effective that Supabase doesn't? Would be my challenge. I don't think there's anything anymore. And I think that's the issue with Firebase is at the time, their choice to not give you a real server or real ways to work with a server were slightly better and let you move slightly faster. But now we have better solutions that let you move even faster than that. And there's nothing that I can do on Firebase as a whole that I can't do faster with Supabase plus Next.js plus Vercel. Supabase is kind of new, but it's open source. I don't think Supabase is just one alternative. I think Supabase de-risks Firestore significantly. So actually, I'll go in a bit on this. Firestore risks. I'll even change this to Firebase risks. So these are the risks you're taking when you consume Firebase. Insane potential cost scaling. Firebase's pricing gets awful fast, aggressively awful, aggressively quick. Somebody mentioned Google Graveyard. I don't even know if it's fair to call that out, but I want to. Google's good about not killing their DevTool stuff, so I'm not going to put that in. I think it's a tiny bit unfair. Offboarding hell. Specifically, both client and server are proprietary. What are the Firebase risks? security, platform specific security. If you don't deeply understand Firebase's way of doing things, you're fucked. Yeah. Oh, type safety, LOL. Not modular at all. So each piece is locked in hard. Cool. So these are the risks that are inherent to using Firebase. These are huge risks to take. The cost scaling is miserable, specifically because you can't move off piecemeal. If I pick Supabase, for example, and I decide that Supabase's client kind of sucks, which I've decided Supabase's client kind of sucks, and I want to use Prisma, I can, because Supabase is built on top of a standard. Supabase is PostGRES underneath. So Supabase is way more modular because the pieces are built on top of open source stuff. Supabase has a much happier offboarding story as a result of that because you can switch out specific pieces. It also has a self-hosting story because it's open source and you can run it on your own infra if you need, or you have specific requirements where you need to run things on certain boxes in certain ways for like any of many safety or things like compliance rules, bullshit like that. And it's all open source. So if you have problems, you can theoretically fix them in the open source stuff and upscale all of that. And all of that said, Supabase's pricing is also much, much fairer. So the only reason to use Firebase right now is you're already using it and the cost is sunk and it's too late to move off it. I do not want to create more victims of Firebase's inability to move off. Firebase is lock-in the platform. And I do not want to encourage lock-in for my audience. There's a case for Firebase for mobile push messaging. Not if you own your own server. It's pretty easy to do push notifications hosting your own server nowadays. Expo has fucking SDKs for it now. Actually. But Theo, don't you love bleeding edge? Yes, but your database is the wrong place to bleed. I love making bleeding edge bets on all sorts of fun new things, but I have to de-risk when I make those bets. I need to be certain when I'm betting on some crazy new thing that crazy new thing isn't going to cause all of my users' data to vanish. If it's going to break the web app for a tiny bit and I need to go fix it or roll back, that's fine. But you can't roll back your database from one provider to another. And if you pick Firebase, you're never rolling back anything again. You're in. Your database, in particular, should not be the thing where you're taking the crazy risks. Your database is a phenomenal place to do things nice and safe, and then you build crazy shit on top. And there are somewhat bleeding edge things I like in the database space. Things like PlanetScale. They're a new company that's pretty bleeding edge, but they're building on the oldest and most boring possible shit. PlanetScale is MySQL only. They don't even support Postgres. And they're built on top of Idez, which is an open source MySQL scaling technology. So I, as the developer, know what they're using and understand those technical choices. And I know, most importantly, that the thing on top and the thing it runs on are both standards. It's MySQL that we connect with, and it is like Vitesse, the open source project that it runs on top of. If I ever had a problem with PlanetScale, I can host it myself. I can MySQL dump off it and move on because it's a standard. If Firebase ends up being the wrong call, I'm just fucked. Where's my spectrum? I'd say that like Postgres on RDS would be between Railway and PlanetScale, arguably, but still a little heavy for the things I'm talking about and that I'm trying to recommend. I could do one more sub rant, and I guess this is kind of, it's a combination of the bleeding edge and the Firestore rant. This one more piece is standards are good, man. Like, SQL is dope. Their SQL is old, fast, and pretty good. Since SQL is a lasting open standard, it gives us as developers the ability to use old tools on it, build new tools on it, try old providers, try new providers, host our own shit. Like, you can do whatever. Proprietary, infra, client, database combos are a massive risk with little benefit. I don't want to subtext. Hasura and FAUNA are bad ideas. I want to be very no bullshit about this. If anybody in this community bets on Hasura or FAUNADB, I have failed as a teacher and I am disappointed. Hasura and FAUNADB assume that the database, the API, the permission system, the infrastructure, and the connection method are not only the same problem, but can be solved at the same time in one place as though they are all the same problem. It is a black box that you have no access to the pieces of. So if I build a spectrum here, on one side we have the database. Actually, this isn't even a spectrum. We have a box that is the database. And on the other side here, we have a box that is the user. When we do something with SQL, oh, that's so good. They have it. They have the emoji in the font. I love that so much. So the database will have a server. You own this. In between. So a user makes a request. It goes to the server. The server goes to the DB to get the data. The DB returns the data to the server. And then the server returns that data to the user. This is fine. Especially if the server and the database are in the same warehouse and the server is already connected to the database. These things are very, very close to each other. And if I'm going to break this down here. If let's say the database that we picked here is MySQL, then in here we might have layers. We might have, I'll say this is MySQL on PLANETSCALE. So MySQL on PLANETSCALE has layers to it. There's a layer of MySQL query. So this is like the query layer. And then below that is Vitesse, which is how they actually host the MySQL and make it so performant. And then below here is some infra. I don't know what the infra is. I don't care. I'm pretty sure it's based on Amazon, AWS. Not positive. I don't give a shit though, because I'm hitting this query layer on top. So if I was to be more accurate, these arrows are just hitting this top part. And then PlanetScale handles the rest. The catch here is, if I wanted to move off of off of PlanetScale for any given reason, I can. Compress that down to just that guy. I could then host Vitesse on top of some infra myself. Build a new box here. Show you all the selected. Separate this out a little bit, just to make it a little clearer. Query layer. And then this part here will say our centralized infra. And because the query layer is a standard, I can separate this in this way and no user will ever notice. We can entirely move off of PlanetScale for something else without changing any of these blocks. This is not some infra now, this is our infra. But we're able to make these types of separations, break these parts out and put them wherever we want because all the parts are standards that we have access to. So let's go back up to here and we're going to do the FAUNA Firebase or Hasura way. So the first thing you need to do is delete the server. There is no server here. There is just the database and the user. If only things stayed this simple. Problem is, on the user side, we do have an abstraction. But it isn't an abstraction that is represented via infra. It's an abstraction that's represented via an SDK. I'm going to give this a circle. Proprietary client SDK. So this proprietary client SDK is what we use in the user land. It would actually probably be a bit more sensical to put this within the user box. Come on, let me select everything. So now there's a proprietary client SDK that we use to connect directly to the database that responds directly to here. So what is the database, though? Instead of what will be on top here, because this isn't going to be SQL, because it's FAUNA, Firebase, or Hasura, proprietary query language. I'm going to have to make this box way bigger to handle all the weird bullshit going on inside of it. So we have the proprietary query language within. We have proprietary data store. I have to make this way bigger this way. So make sure these arrows point here because that's where they're actually going. So some things aren't as insanely proprietary on this part, like Hasura is GRAPHQL on the top here. But the GRAPHQL isn't a shape that you defined. The GRAPHQL is directly tied to how the proprietary data store has things shaped within it. All of this exists in a config inside of your, like, whatever of these providers you're using. So this is database, server, hybrid, you don't own and can't leave. I really like how Alex, the TRPC dev, explained specifically Hasura. It makes the easy problems slightly easier, and it makes the hard problems nigh impossible. It makes life rough. And I'm not just saying that to say it. I'm saying, like, once you get into weird permission systems, once you get into any of the hard problems that we as developers solve every day, Firebase and Hasura, they get in your way. They don't solve the problems. And if you have those problems, you have to hope that these providers built a good enough way for you to go use and understand and buy into really heavily. Neo4j, this isn't the case for, because Neo4j is an open source thing. You can go host it yourself. In fact, I think you have to. EdgeDB is similar, where you couldn't use, I don't even know if their cloud platform is publicly available yet, but a lot of those things are open source standards where you have to self-host, or at the very least have the option to self-host. The problem here isn't that, like, whatever the technology that is Fauna and Fauna's query language is inherently toxic and bad. It's you have no ownership of the server where your stuff's actually resolved. When a user asks for their friends, so if I'm a user and I say, I want my friends, you have to hope that this has the right way to fetch your friends. And let's say for whatever reason, your system is secure in a way where you want a user to have access to their friends and nobody else's. You better fucking hope that whichever solution you picked here has an easy way to restrict a subset of a user object from other users with a good relational model where you can fetch those other users underneath them with some type of security method on top. The amount you have to buy into here is at every layer. You either have to use the client SDK or you have to do some crazy custom HTTP requests. You have to use their host, period. You can't get out of that. You have to use their data store and their infra as well. You have to use their configuration, their permissions, their everything once you've bought in. Whereas with a solution here, let's go back to like the user fetching their friends example. a user could make the request, get my friends. And the server will check that request. It will check the authentication to make sure, to figure out which user you are. The request itself doesn't say which user to get the things for. It literally just says, get my friends. And the server uses the cookie to figure out who you are and return your friends. Now, without that cookie, without that authorization, you cannot get that data because there's no other method to get here. Whereas in the Fauna land, in the Hasura way, the client is describing exactly what it needs so the server can give it back. Because you don't own the server, you don't have the ability to infer anything, you don't have the ability to permit or block anything. You've given up all ownership of the relationship between your data and your client. And there is a relationship there. Similar to how I was saying most databases need relations at some point, most data client architectures need a relationship at some point. Fauna's great if you don't care about the shape of your data, never have to care about the shape of your data, don't care about the permissions of your data, and never have to care about the permissions of your data. Chances are you have to do at least one of those four things. Honestly, chances are you have to do all four. You could just run FQL on a Lambda with your own API. Have you ever seen someone do that? Let's see if Fauna recommends that type of thing anywhere in their docs. I am genuinely curious because I know you can run any client anywhere, but I think that's absolute fucking bullshit. Is there docs somewhere? I have like a getting started or something in here. Quick start. None of these seem like they're going to be hosted by you. See if the GraphQL one is, or create a GraphQL database. No. Okay, so all the examples here are how you use Fauna as your server and then connect to that from your client. Developing with FQL. Cool. Here's what we're going to do. Python is a pretty popular programming language for servers. We can agree on that, right? Can we agree on that? Python is a language people use for servers. This package here is open source. If this package has less than 50 stars, I am not entertaining that people use Fauna on servers. If this package has over 100 stars, I'll eat my shit. I was wrong. And if it's between 50 and 100, not valuable. Let's see. Fuck! Y'all can't see it because of my camera being in the way. What's the easiest way to unfull screen? It's 114 stars. Literally right on the goddamn line. Fine. I guess some people use Fauna on the server. I will take the L. There are people who do this, I guess. I don't recommend it, but there are people who do it. It's not a lot of people, but it's enough people. I want to be clear. Like this wasn't this isn't about not many people use it. It does anybody actually use this thing? And there's a number of people who cared enough to hit the star button. There's 182 who hit it for FAUNADB Go. I think they've been conned. FAUNADB.js is the one that works in the client too. That makes sense. It's also not TypeScript, which is painful. Yep, this driver supports Chrome, etc. This is the one that works on the client. Yeah, what are the weekly downloads? We can't really check that for something that isn't JS. There isn't an easy enough way to see how many downloads something gets on PNPM. Yeah. I don't see it. Fauna feels like someone saw the opportunity that was represented by Prisma's success, and they wanted to wipe out everything below it so that you would get bought in and stuck. And I get that, but I don't think it makes sense. Yeah, This was a long rant. I did not know I had this much to talk about with databases. But yeah. It looks like you can use Fauna on a backend, and God forbid there are actually people who do it. Yeah. So where did I have the, like, what did we learn here? Yeah, this all lines up. SQL is great. Use it if you can. There are real DX wins coming from a lot of these different things. Even Fauna has some. Please be careful if you choose Mongo. Please don't use Firestore or things like this without very good reason, and I don't think those reasons exist. And servers and APIs are a good thing, and you should probably build them now that they are so easy to build. FAUNADB stats on PyPy. Let's see. 15K downloads in the past month. People are using it. I don't like it, but they are. I don't think it's fair to just write it off as bots in CI/CD, Jake. Like, you can do the same thing with other projects too. I will say one of the few you can't write off is Create T3 app, because you only install Create T3 app when you use it and then never again. Unlike other packages on NPM, where every time you push your code, it re-NPM installs all of the packages and has to fetch all of those again. I hope you learned something about databases here. They kind of suck, but they don't suck that bad. The problem that I see causing people to reach for substandard and less than ideal solutions is usually not that databases are hard, it's that servers are hard. So if you find yourself reaching for things like Hasura and Fauna, or still leaning on things like Mongo and Worker KV really heavily, take a step back and think, why? Why am I picking these solutions that skip the server? And what problems am I going to run into in the future? I highly recommend owning a server of some form, be it a Lambda through Next.js, an Express app, a Golang or Python, whatever instance that connects to your database, handles permissions and data shapes and APIs and all the things you might need to do with that data, because the relationship between your database and your client is inherently somewhat complex. And pretending that it isn't, and that there's a piece in the middle that isn't necessary, is going to cause constant pain. If you take anything from me here, please let it be this. Put a server between your data and your client of some form. It will help you a lot. Thank you. Shout out to Idez if he edited this. Shout out to me if he didn't. Not sure who it will be just yet because he's on vacation and I'm really busy. Make some cool stuff. Make sure you subscribe, because way less than half of you have subscribed and we need to raise that number. We're only at a little under 40K subs. We should be at 100 right now based on the viewership. Hit that sub button.